Imagine a future where the universe doesn't simply fade away. It tears itself apart. A future where galaxies stretch until they snap, where stars rip open like paper, where planets crumble grain by grain, and where even atoms, the very building blocks of matter, are pulled into oblivion. This is the Big Rip, the most dramatic theoretical end of the universe ever proposed. And if it's true, then everything we know, space, time, physics, has an expiration date written into the fabric of reality itself. If the thought of the universe tearing itself apart sparks your curiosity or your existential dread, make sure you stay with us through this journey. And if you want to explore more mind-bending cosmic mysteries, consider subscribing so you never miss the next deep dive into the strangest corners of the universe. Now, let's begin with the question no one wants to ask. The Big Rip begins with a simple but unsettling idea. What if the force that accelerates the expansion of the universe, dark energy, is not constant? What if it's growing stronger? If so, then the universe isn't just expanding, it's accelerating toward destruction. Unlike the peaceful heat death or the symmetrical Big Crunch, the Big Rip is chaotic, violent, relentless. It imagines a universe that stretches faster and faster until even the strongest forces can no longer hold matter together. To understand the Big Rip, we must understand dark energy, an invisible, mysterious pressure that makes up nearly 70% of the universe. It's responsible for the accelerating expansion of cosmic space. But here's the problem. We don't know what dark energy is, and because we don't know what it is, we don't know how it will behave in the distant future. If dark energy strengthens over time, the expansion rate increases, slightly at first, then dramatically, then catastrophically. Eventually, the expansion doesn't just separate galaxies, it begins to overwhelm gravity, electromagnetism, and even the nuclear forces holding atoms together. The very laws of physics bend under its pressure. In the Big Rip scenario, destruction unfolds in stages. First, galaxy clusters drift apart, marooning each galaxy in its own isolated bubble of space. Then galaxies themselves begin to unravel, their stars no longer gravitationally bound. Over millions of years, stars break loose, drifting into cold emptiness. Later, dark energy tears apart planetary systems, unraveling orbits and scattering worlds. As the rip accelerates, the destruction becomes more intimate. Earth-like planets fracture, the atoms in your body stretch, the nuclei in those atoms lose their cohesion. And finally, as the expansion rate reaches infinity, even space-time, the stage on which the universe plays out, ceases to exist. This is the absolute erasure of everything. Billions of years before the final moment, galaxies experience the earliest consequences. Gravity, the glue that holds them together, slowly loses the competition against an ever-strengthening expansion. Stars drift away from one another. Spiral arms unwind. Supermassive black holes, once the anchors of galactic centers, can no longer reel in the matter around them. Imagine the Milky Way stretched thinner and thinner until its elegant spiral structure dissolves into a lonely smear of stars. The local group, once a cosmic family of galaxies, becomes a scattering of orphans drifting through a rapidly expanding void. Eventually, the Big Rip becomes personal. Stars lose their planets as their gravitational hold weakens. Orbits unravel like tossed rope. Planets with stable, predictable paths spiral outward into interstellar darkness. No solar system survives. Not ours, not any. Even worlds far from their stars fall to the same fate. Moons detach from planets. Asteroids drift into oblivion. Comets tear apart before they ever approach their parent suns again. The intricate clockwork of celestial mechanics simply fails. Closer to the end, dark energy's influence becomes so overwhelming that planets themselves cannot hold together. Earth-like worlds fracture. Gas giants expand until their atmospheres peel away. Rocky planets split along their fault lines. Mountains crumble, oceans evaporate. The cores of worlds crack open. Gravitational cohesion, the force that binds a planet into a sphere, can no longer resist the universal stretching. Planetary destruction is no longer an astronomical event, but a fundamentally physical one. Stars resist longer, but not forever. The nuclear fusion engines that power them rely on gravity to maintain incredible pressures. But under the influence of runaway expansion, that balance fails. Even stars, objects so dense that a teaspoon of their material can weigh tons, come undone. Their outer layers lift away, their cores unravel, supernova remnants disperse. White dwarfs, neutron stars, red giants, none are spared. Even black holes, which can normally withstand anything the universe throws at them, are not immune. As space-time stretches, their event horizons disintegrate. In the Big Rip, not even darkness survives. Moments before the final end, destruction reaches the smallest scales of reality. Atoms stretch, electrons spiral away from their nuclei. The strong nuclear force, normally so unbreakable it holds quarks together, loses its grip. Subatomic particles dissolve. Nothing in physics remains strong enough to resist the expansion. Even fundamental particles become meaningless, as space-time itself, distance, direction, dimension, destroys the very concept of location. Matter doesn't just die, it becomes impossible. What survives after everything ends? The shocking answer is simple: nothing. Unlike the heat death or the big crunch, the Big Rip leaves no remnants, no cold debris, no collapsed singularity, no frozen, empty vacuum. Because space itself has been torn apart, the universe ends without a trace. There is no after, because there is no time. There is no location, because there is no space. The universe doesn't collapse or fade, it stops being a universe altogether. It is the ultimate shutdown of reality. And in that stark finality lies a strange, humbling beauty. Everything we know exists only because the universe currently allows it. The Big Rip may occur trillions of years from now, but studying it teaches us about the universe's most mysterious ingredient, dark energy. The more we understand its behavior, the better we understand the fate of the cosmos. Is dark energy constant, changing, increasing? Each possibility leads to a radically different future. The Big Rip is not a prediction, it's a test case. It challenges our theories, expands our imagination, and pushes physics into territories no scientist can ignore. The universe's fate is written in dark energy's nature, and uncovering that nature is one of science's greatest quests. The Big Rip forces us to accept something profound. The universe is not stable by default. It exists in a delicate balance between forces we barely understand. Life emerges only in a narrow window where stars shine, galaxies form, and physics behaves predictably. We live inside that window. Our existence is a temporary harmony between cosmic forces, and understanding how fragile that harmony is makes the universe feel more precious, more fleeting, more extraordinary. The Big Rip is not merely a terrifying possibility. It is a reminder of how remarkable the present moment is. We exist in a universe filled with galaxies, stars, and worlds, structures that might one day be impossible. We are observers, living in the brief era when the cosmos can be understood, explored, and appreciated. And as we continue to ask questions, measure the sky, and unravel the mysteries of dark energy, we participate in the universe's greatest story, the story of itself. If this journey into the end of everything has fascinated you, consider subscribing. Our universe is filled with wonders, and together we'll explore every one of them.